C++ Programming Comprehensive, Chapter 2, Unit 2. Member function scope within the class. Places each function within the scope of the class to which it belongs to. Basically, each member function is in the scope of a class where it can see its own data members. So the member function's responsibility is to be able to operate on the data that it has, the data members within the class. Each function enjoys special access privileges to other members of the class. Since the member function is part of the class, it has easy access to all the members within the body of the class. No need to specify the class instance to access the data members. So there is no need to use the object or create an instance of a class to access the data members, because the member function is part of the class. So therefore you do not need to create an object within the body of the member function. Directly access the data members. Member functions do not take up any room inside the object. Okay. What does basically that means? It means when you create an object of some class type, that object will be allocated in the memory somewhere, and the size of the object will depend upon how many data members are within the class body. So in this case, in this example, we have 2 data members. Okay, and just for the purpose of understanding, let's keep things a little simpler and say that we have a processor which is which has a integer type 2 bytes. So if I say that, then the object, once I create the object of C rectangle type, okay, this object of C rectangle type will have the width in there and height. Okay, width and height will be within the object, but the member function is not going to be there. Of course, this object will be created in the memory at some memory location, let's say 1000, and then the object name may be of type that C rectangle, say XYZ. Okay, whatever the name that you want to give to that object. So that will be the label on the memory. But the main thing to understand, this object will be of size 4 bytes. When you do the size of operator, okay, so if I do the size of X, Y, Z, it will return 4 bytes. Okay, 4 bytes will be returned. So let's look at this example 2-1 and try to understand what is exactly happening within this example. Starting with line number 0, I have a header file with Iostream. Okay, this is the Iostream header file, and as we have just in unit 1, we went over what the namespaces are, and here I am actually using that keyword, using namespace. Okay, and I'm saying because I am using this std, which the namespace is already a part of your C++ compiler. Okay, the purpose of this is that I am declaring is because so I don't have to repeat this std with where every place where I use a cout object, okay, with the scope resolution operator. So that is the reason that line number 1 is declared. So I do not need to repeat the std namespace every place where I have a cout object or cin object. At line number 3, I am starting the declaration of a class called cRectangle. Okay, so this is the start of the class, left curly braces, and then at line number 4, I'm saying what class members are going to be protected, meaning will be hidden from the outside world by putting them in under the private section. So private is a keyword followed by the colon. Okay, that means anything under the private you cannot access them from a non-member function such as main. Okay, when you use a dot operator and try to access the m_n width or m_n height, you will get a compilation error. And then at line number 8, I have a public keyword used, followed by the colon. So under the public keyword, I have 2 member functions. So the reason I put these member functions under the public is because I want to be able to access these member functions from a non-member, okay, which is main. So when I create an object within the main, I can use a dot operator to access the set size and an area function. And at line number 11, I end the class. Okay, please do not forget the semicolon. As I told you in the first chapter, that if you forget the semicolon, you will have at least about 100 errors during the compilation. So this ends the body of the class. Now remember also that no memory is allocated when you declare the class, when you give a class definition. There is no memory allocated at that point. The memory is going to be allocated when you actually create an object, okay? And that we'll see it in the next slide. So in the next slide, I have two member functions, set size and area. The body of them is outside. We declare the prototype within the class body. So at line number 13, the body of the set size starts, and notice that we have to tell the compiler that set size is in the scope of a cRectangle, and that's why we are using a scope resolution operator right here, and the name of the class, cRectangle. And within the body of the function at line number 15 and 16, all I'm doing is initializing these 2 data members, which a function can see directly. The set size function can see these both data members directly. So these data members will be initialized to whatever the parameter would be passed when the function is called. Okay, so the height and width will be initialized with those parameters. And then at line number 19, my area function starts. Similarly, area function the compiler must be told that the area function is a member of the cRectangle. So that's why there is a scope resolution operator in the cRectangle class name. Also notice that the return type is there, okay, for the function. This return type int. That means this function is returning an int. In the previous case, the set size, I have a word right here. Okay, so that means it's returning nothing. Make sure you understand that every function must have some return type. If you don't put the return type right here, okay, by default it will be coming int. So by default, every function returns int, unless you say that okay, I don't want any return type. So in this case, the function area can see width and height directly, because this area is a member of a class, C rectangle class. It has a special privileges to see these both data members. All it is doing is that it is multiplying these two values or two data members. Whatever the data is at that memory location, it will be multiplied. And this at line number 22, it ends. Okay, so the indentation is a little bit off, but it ends at line number 22, this area function. And then at line number 24, a main function starts. So in main function, notice that I have two objects. Object 1, rec 1. Okay, this is rec 1 and rec 2. So the two objects that are created. Okay, so that means I have these two objects, rec 1, and then rec 2 in the memory. So when I create these at line number 26, okay, these objects, or you can also call two instances of C rectangle. Now, just to have a quick review, object, when we say it's an object, that means it has a characteristics and behavior. Okay, so what is the characteristics? In our case, this characteristics is height and width. Height and width is the characteristics. What is the behavior? The behaviors are the member function names, area and set size. These are the behaviors. Okay, so that's why we call them object. So in this case, the objects will be allocated, once I declare these objects, will be allocated somewhere in the memory, maybe a location 1000 and 2000. Okay, and within these objects there will be only a data member. Okay, two data members are going to be there, width and height. Similarly, width and height. The size of this object is going to be, assuming that your integer takes up 2 bytes. Okay, so this will be 4 bytes right here and 4 bytes right here. Okay, so that many bytes will be allocated because I have 2 objects, so I will be allocating 8 bytes. Notice that there is no room for the member functions. Okay, member functions don't need a room, and we will see that in next example why they don't need any room within this object. So once I create the memory or allocate the memory, where is the memory is going to be allocated? On line number 26, I allocate the memory, but where? What part of the memory? These both objects are going to be actually on the stack. Okay, so line number 26 allocates the memory on the stack. And without allocating the memory, you cannot call the functions. Okay, so once you have the objects, then you can use these objects, like I'm doing it in line number 27 and 28, to call the member functions. Okay, so line number 27 is calling the member function set size by using a dot operator right here. Okay, and then similarly, rectangle 2 object, or rec 2 object is using a dot operator to call the set size member function. Notice that I hard coded the value as a parameters to the function. Okay, so when it is called, this set size is called, it actually will have some value. The W and H will have the value which will be assigned to the data member width and height. So at line number 29, all I'm doing is displaying this string on the console window. Okay, by giving it to the cout, it will just put this message on the console window. At line number 30, all I'm doing is calling the area function. Now, as you notice, that area function is doing not much. It is just returning the value. Okay, the value after it multiplying the width and height. So it will figure out what the value is, and it will return to that value, and the cout object job is to display that value. Okay, and then at line number 31, all I'm doing is displaying that string, and then same thing at line number 32, calling the area function in relation to this object rect2. Okay, so let's look at the some pictures on the next slide. So what I was drawing is like right here, rect1 and rect2. Okay, so and this is the output. This is the output that you will see once the program stops finishing running. Next slide. Let's look at what this pointer is. Okay. It is very important that you know the pointers in C, and of course in C++. So pointers in C and C++ is the same. Okay. Basically, the concept of pointer is that you allocate the memory, okay, of that would be a type of pointer that can only hold the addresses. Okay, that's the concept about the pointers. So you have a memory that will only hold the address of some other memory. So in just a very quick review here, if I have int x, okay, equals to 10, and then int star ptr, okay. So what did I do just now? By doing these two lines, I allocated the memory, okay, that has value 10 in here, and the memory name is x, and it is at some memory location, let's say 1000, and then I have allocated another piece of memory right here, and the memory name or the label for the memory is ptr, okay. And in this case I did not assign this memory, but remember, this memory can only hold the address within here, okay. It cannot hold the value. So what I'm trying to say is that you can put the address of this x in here. How are you going to do that? You just say ptr equals to n% x. Okay. Now, as soon as we did this statement, then we are putting a 1000 in here. So this piece of memory now is pointing to here. So if you want to access 10, you will have to do the dereferencing, okay, on the PTR. So star PTR, I can change the value on that and put 100. So I access the memory and then I change the value on here by actually I put in 1000. So I write 1000 in here. Okay, so this is a quick review of the pointers. So this pointer is no different than the regular pointers, except that it is a special pointer. It can hold the addresses of an object. That's the difference. It can hold the addresses of an object. Okay. Now, C++ in many ways will add some extra code during the compilation. Okay. It will insert some extra code for you without your knowledge. You won't even know that during the compilation some extra code was inserted. Okay. And one of the things that it also inserts this pointer. Okay. So where does it insert this pointer? It actually inserts this pointer in the member functions parameter list. Okay. Even though there may not be any parameters by the user, but it will insert this pointer parameter. So let's look at it, what exactly this pointer is. So this pointer is automatically passed when any member function is called. Okay, as I told you just now, that it is inserted automatically by the compiler. Okay, so during the runtime, it is automatically passed. So it is a pointer to the object that generates the call. So it will insert what type it is going to be, first of all, to understand. When the compiler inserts this pointer in the parameter list, okay, it will make that pointer the same type as it is as a class name. Same type as the class name. Because that member function belongs to that particular class, then this pointer will be of that particular class type name. So basically, that is the reason is that bullet says it is a pointer to the object that generates the call. Okay. So when the call is generated, this pointer holds the object. Whichever the object make the call to the member function, okay, whichever object made the call to that particular member function, that object's address will be passed, okay, or put in to this pointer. So this pointer cannot, so we'll discuss more while I'm going in the example, okay. So this pointer cannot be assigned any addresses. So you cannot change the addresses of this pointer. So once this pointer is holding the address of any particular object, that's it. It's a constant. It cannot be changed. So let's look at this small example, and during the example I will go over more about this pointer. Yeah. So before I start this example, make sure you understand that this is a keyword in C++, all small characters. Okay, and it holds the address of an object. Alright. At line number 0, I have include Iostream. Okay. We already talked about it in the previous examples, that the Iostream is a class, is a header file that has a class Iostream, or well, actually it has also Iostream and Ostream, and it provides the function. It provides the objects for us: cout object and cin object. Okay, and then line number 1 includes the C string. C string is basically similar to a string class in C, a string header file in C. So the purpose that we will be using is a string copy function. And then at line number 3 I have using namespace, okay, std. We already have discussed it. The purpose of this line is so I do not have to repeat std keyword in front of the cout or cin object. Okay, at line number 5 I have a class definition, starting the class definition. Okay, so the class name is C employee, and I already have told you in my first lecture, or in my first chapter, that the reason that I put a C in front of the name of the class is just for the readability purpose, so I know if in any place in the code that I've used, right away by reading it, the code, I would know it is a class name, not a structure name. Okay, so class definition starts at line number 5, and line number 6. Now notice that I have a public keyword right there. Okay, so as soon as I start a class, I make the class a public. Okay, why is that? Because as you remember that in chapter number 1 we discussed that classes defaults to private and structures defaults to public. So if the class is defaults to private, that means by using a dot operator from a non-member function, I would not be able to access init or display function unless I make this class start with a public. Okay, so I'm basically changing the default behavior of a class. So at line number 7 and 8 I have a two member functions, init and display. So init is taking 3 different parameters: character constant and 2 integer type parameters, and display function is taking no parameters. Now remember, right now the way that we have written, there are no parameters for the display. Okay, but as I told you, during the compilation, compiler will insert a this pointer. Okay, so depending upon the compiler manufacturer, sometimes the this pointer is inserted at the end, so at the end of the parameter right here, okay, or sometimes in the start of the parameter right here. The this pointer will be of type C employee. So when compiler will insert, it will say C and then this, okay, that's what compiler will insert. Remember, you do not insert yourself. Okay, you do not type this thing in your code. It's compiler's job during the compilation to insert this pointer in the parameter list. Okay, and you will see the purpose pretty soon why it has to do it when I go to the next slide. So at line number 9 I'm saying, okay, enough for the public members. I want to make the rest of the members a private. Why? Because I want to hide those members. I want to hide those members from the outside world. I don't want any object to access them directly from the non-member functions. So by putting them under the private section, the objects would not be allowed to access them. Okay. So m underscore AC name, m underscore NID num, m underscore N age, they all are data members, okay, and they all are not accessible by using a dot operator from a non-member function. Definitely you can access them directly with the member function, okay, like we discussed in the last example. And then I end the class definition at line number 13 with the right braces and then the semicolon, okay. So now this is the body for init function right here, init function, okay, and the body for the display function. So let's go into more detail. So init body starts at line number 16. And notice that I'm using a string copy function. Okay? The only way it will work is if I would have included the string class. See, string class, you saw that in the right before the declaration of the class. So C string header file is already declared, okay, and that's why I can use the string copy function. Now, within the string copy function, notice that at line number 18, I'm saying this, okay, arrow m underscore ac name. Okay, where is this coming from? Okay, this is nowhere anywhere in the body of the function. So where is it coming from? As I told you in the last slide, that compiler will insert this right after this parameter a. Okay, during the compilation it will insert this pointer. Now does that mean that you have to always use this arrow m underscore this? No, not really. The purpose of me putting it in here is so you understand what is that this means. Okay, so I'll draw some diagram right here so you will have a clear picture of what is happening. But let's first finish this piece of code. At line number 19, I'm using this pointer again. Okay, this arrow m underscore num. Okay, so m underscore id num is basically a data member for the C employee class. And at line number 20, I'm doing the same thing. This underscore arrow m underscore n age. Okay, that is a data member of a C employee class. So now this pointer basically is accessing the data members. Okay, so let me finish this display function, and then we will really discuss this in the next slide, how this pointer is able to utilize these data members. Okay, or even if it is necessary to declare this pointer this way. So at line number 23, I have a display function. Okay, in the display function, even though there are no parameter, there will be at least one single parameter right here. Okay, it will be this pointer right here of type C employee. Okay, how is this going to come? During the compilation, compiler will insert that. So that's why once this parameter is there, compiler, when it comes to this line number 25, it would not complain, because it sees that, oh, there is some identifier there which is allowing the data member to be accessed. Okay, so at line number 25, it's happening the same thing as I'm accessing the data member, okay, name. And line number 26, the same thing, data member NID num, and then age, same things. Okay, but let's look at the next slide and come back to the slide for more better understanding of this pointer. So in this slide, what I am doing, in this slide I am creating one single object, okay, worker data. So I'm going to create a worker data right here. Okay, this object, how many things this object will have? Okay, how many members this object will have? This object will have 3 data members: a name, okay, ID num, and the age. So those are the 3 things this object will have: name, ID, and then the age. Okay. But this object name, which is the worker data, okay, that's the name of the object. It is somewhere in some memory. Let's say 5,000. Okay, address. So this memory was allocated for this object, and it has that address. Now, at line number 33, what happens? At line number 33, this worker data is calling the init function, okay, by using a dot operator. So when it calls the init function, it will pass, okay, so the worker data will not pass, the worker data will initialize its own address to this pointer, which is right here. Okay, so that is compiler's job to assign it. When the object makes a call to the function, that compiler's responsibility is to assign that particular object's address to this pointer. Okay, so in our case, I'm just as I'm giving you the example, that this pointer, okay, will be assigned with 5,000. Okay, and that's how this pointer knows where the data is located in the memory. Okay, that's how this pointer knows where the data is located, or the data is supposed to be located. So if you see this right here in the previous example, in the previous slide, when this init is called, okay, this pointer, as I told you, will be holding the address 5,000. Okay, so it is saying that go to the address 5,000 and go and assign this name that is passed right here in the slide, Johnson. Okay, assign or copy that Johnson, which is coming from this name right here. Okay, right here, this it's coming from here. Copy that to the array. You know, so string copy job is to copy that name Johnson to the that array. Okay, so that's how it knows. Similarly, this one is 5,000. Okay, so this is holding 5,000 value, the address, because of this next slide right here. Okay, because I created the object at location 5,000, so that means this will be holding the address 5,000, so it will be putting this ID at that particular location 5,000. So 5,000 something, right? Not exactly the 5,000, because the compiler will figure it out, you know, by using the base address, which is 5,000 plus whatever the array size is. In our case, if you go to the very first slide about this example, it's 20. So 20. So it will be 20 bytes. Okay. After the 20 byte, the data space for the num will start. Okay. So 5020. So 5021. This will be written. This data. Okay. So this data, that, as we said, is an integer type, and it's maybe 2 bytes. As we have been talking about it. So the age will be written at what location? 5023. Okay. So I hope you understand now how this pointer is holding the address of an object which made the call to the particular function. Okay. In this case, the init was called. Okay. So if I would have W2, for example, object. Let's say I create another W2 object. So this is the worker data object. And if I create W2 object, okay, W2 object, and then it will have same data members, name, okay, ID, ID, and the age. Okay. These three things are going to be there. And let's say this object was created at address 9000. Okay. So when I make a call by using this W2 dot init and then pass this string, okay, and then some number 9010 or 9001, and then 37. Okay. So in this case now, what will be the address that this pointer will be holding? Okay. So there is a this pointer right here, right? This pointer, the compiler will insert this pointer right here. So that this pointer will be holding address 9000. Okay, because we are calling it with this object W2. So that's how basically your member functions know where the data is located because of this pointer. And that is the reason that this pointers, that is the reason that the member functions do not allocate any memory within the objects, any objects. Okay? Because member functions are told, okay, by the object that where the memory is. Okay, because of the parameter that they hold, the this in their parameter list, which is that parameter is inserted by your compiler during the compilation time. Okay, so similar things will happen with the display. So the display function will know where the memory is located because this will be 5000 right here. Okay, that means this object right here. So 5000 dot display. So this pointer which is in this parameter list for the display, it will go directly to here, and read the memory for name, age, and ID and age. So if I would call the W2 dot display, okay, that means that the W2 address will be passed right here through this pointer. So this pointer, okay, will be holding the address 9000. Okay. Now, what is located at address 9000? All this data. So different data than address 5000. Okay. So now this display, which is called by W2, will display the data which is at location 9000. So that's why we say that the member functions do not allocate any memory within the object. Okay? They have a special privileges. How they get the special privileges? By getting this pointer's address in their parameter list and knowing where the data is located. Okay, so this is an end of unit 2 in chapter 2.